Hello, today we're going to start with Unit 4, our last unit of the semester, and it is called So You're Saying There's a Chance. So let's see what it's all about. Our quote of the day, let's go ahead and turn to the workbook here. Our quote of the lesson says, "A scientist worthy of a lab coat should be able to make original discoveries while wearing a clown suit or give a lecture in a high squeaky voice from inhaling helium." Okay, it is written nowhere in the math of probability theory that one may have no fun. I'm not sure what that shit's all about. What that quote's all about. Sounded like I said something else, but I didn't. Anyway, we're talking about chance. We're talking about probability. We're talking about things that we can kind of predict and things we can't really predict. So down here at the bottom of page 365, it says, in this lesson, we'll examine the basic concepts involved in studying probability. In short, the probability of something occurring is a number that represents how likely it is to occur. You can think of it as the perfect chance of something happening. The major difference between percent chance and probability is that we write probability as a number between 0 and 1. So like a decimal, we would think of it as. So in that regard, it's like percent chance with a percentage written in decimal or fractional form. So a forecaster says that there's a 70% chance of rain today. What is the probability of rain? So all we're going to do is write that percent in decimal form. Okay. So when we talk about probability, processes such as flipping a coin, I have a quarter here, rolling the dice, or drawing cards from a deck are called probability experiments. A probability experiment is a process that leads to well-defined results called outcomes. An outcome is the result of a single trial of a probability experiment. But probability, you can think of getting in a car accident as a probability too. It's the likelihood of that outcome happening. And there's 3 types of probability that we're going to learn about. So it says in a probability experiment, we can predict what outcomes are possible, but we can't make any definite statements about which one will occur for any given trial. We say that outcomes occur at random. In any probability experiment, the set of all possible outcomes is the sample space. So list out the sample space for each probability experiment. Flipping a coin. So when you flip a coin, there's only 2 outcomes in the sample space, either right here, heads or tails. Rolling a standard die. A standard die is 6-sided. So its sample space would be the listing of 1 through 6. And notice they're in the squiggly brackets. That's whenever we're going to list outcomes. Answering a true-false question. That one only has 2 outcomes, true, right and wrong, true and false. And the last is flipping 2 coins. So the key here is to think of the experiment as a sequence of 2 flips. You could get either heads or tails on the first. Then once you know what came up first, you could also get heads or tails on the second. So the sample space is heads, then heads, heads, then tails, tails, then heads, tails, then tails. And we're going to learn how to draw what we call a tree diagram to describe letter D later. So number 2 says, write the sample space for the probability experiment of identifying the student's graded chemistry course. So in a chemistry course, you could have a 0, a 0.5, a 1.0, a 1.5, a 2.0, a 2.5, a 3.0, 3.5, a 4.0, and you could also have an incomplete. So when studying probability, it's pretty common to think about several outcomes of an experiment that are related in some way. For example, when rolling a die, we might be interested in whether the result is odd. Write all the outcomes of rolling 1 die that are odd. So here are all the outcomes of rolling a 6-sided die. The ones that are odd are 1, 3, and 6. And so we're going to list those as 1, 3, and 6. So you just wrote an example of an event. So this is an event. An event is right here, is a collection of one or more outcomes in a sample space. Some events, like rolling a 3 with one die, have only one outcome. Others, like rolling an odd number, have more than one outcome. There's a subtle distinction between an outcome and an event. An outcome is a singular occurrence, while an event can contain a number of outcomes. So rolling 3 with a single die is an outcome, but it can also be considered an event. Rolling an odd number, on the other hand, is an event made up of 3 outcomes, but is not itself an outcome. Let's look at the distinction more closely. Look back at the sample space for flipping 2 coins. How many results match getting heads on the first flip and tails on the second? Heads on the first flip and tails on the second, right here. Heads, then tails. It looks like only one of them. That's an outcome. How many results match getting one head and one tail? Okay, one head and one tail. So we could have heads, then tails. Or we could have tails, then heads. This is an event. Heads and tails, tails and heads. It's getting one head and one tail. They're two different outcomes. That's an event. So identify each scenario as an event and outcome or both. When rolling 2 dice, getting 3 on the first die and 5 on the second. That is an event. Remember, an event is a collection of one or more outcomes in a sample space. Some events, like rolling a 3 with one die, have only one outcome. Others, like rolling an odd number, have more than one outcome. So when rolling 2 dice, getting 3 on the first die and 5 on the second, that is an event. I'm sorry, this is an outcome. That's an outcome. When rolling 2 dice, it's an outcome because an outcome is the result of a single trial of a probability experiment. So a single trial, you could get a 3 on the first dice and a 5 on the second. When rolling 2 dice, getting a total of 10. Okay, this is an event because an event is a collection of one or more outcomes in the sample space. And so getting a total of 10 can happen in many different ways. So this is an event. When flipping a coin 10 times consecutively, getting tails 8 times. That's an event. Okay. So one type of probability that we're going to talk about is called theoretical probability. Theoretical probability is the first type that we're going to study. The goal is to identify all the possible outcomes in the sample space and calculate the probability or likelihood of an event occurring without actually performing experiments. There is one key assumption we make in theoretical probability, that every outcome in a sample space is equally likely. Okay. Okay. Every outcome is equally likely. For example, when a single die is rolled, we assume that each number is equally likely to come up. When a card is chosen from a deck of 52 cards, we assume that each card has the same probability of being drawn. Okay, so this is theoretical probability. You'd have to be awfully bored to flip a coin 100 times, but if you did, about how many times do you think it would land tails up? So we would think 50-50, right? 50 out of the 100. what percentage of this time would you expect the coin to land 50 tails up? So 50 times. And so that means 50 out of 100 would be 1/2 or 50%. This is your lesson check for lesson 4.1. Write a fraction with the number of flips in the denominator and the number of times you're expecting it to land tails up in the numerator. What does this have to do with your answer to question 10? So we already did this. 50 times we would think this landing tails up out of the 100 flips. So we're just saying this is these 50%, 0.5, and 50 out of 100 are all ways to write probability. And so the probability of an event E in a sample space S occurring is given by this: the number of outcomes in the event and the number of outcomes in the sample space. So let's think about this. For questions 12 through 14, a single-sided, six-sided die is rolled. Find the probability of each event. If you need to look back at the sample space from self-example 1. And that was where we had the 6 outcomes. Rolling a 2. So there's only one way to roll a 2. So that would be rolling a 2. Number of 2s out of sample space. So there's 1 2 out of 6. And we could write this as a fraction. We could also write this as a decimal. Or we could write this as a percent. All of those ways. What about rolling a number less than 5? So rolling a number strictly less than 5. So we're going to say the probability of X is the number rolled. Probably the X is strictly less than 5. Would be 1, 2, 3, or 4. Any of those that come up is less than 5. So the number of less than 5 is 4 out of 6, or 2/3, or 0.67, or 67%. Rolling an odd number. So the probability of X being an odd. And so X being an odd, we said there's 1, 3, and 5. So 3 out of the 6 times would be 1/2, which is 0.5, which is 50%. Okay. So let's say we have 3 coins. Write the sample space. Remember that tails, heads is a different outcome than heads. Tails, even though both result in 1 tail and 2 heads, which by the way sounds like a bunny rabbit. Anyway, let's say we've got 3 coins. So we've got coin 1, we have heads and tails. Once we flipped coin 1, we have to flip coin 2. So on coin 1, we could have had a heads, and then on coin 2, we could also have a heads and a tails. On coin 1, we could have had a tails, but then on coin 2, we could still have a heads or a tails. Then we're going to flip coin 3. So coin 3 could also have a heads and a tails. So we have 1, 2, 3, 4, 5, 6, 7, 8 in our sample space. So I'm going to write my sample space is actually the final outcomes. So my sample space is heads, heads, and heads right here. Heads, heads, and heads. I could also have had heads, heads, and then a tails on the last one. We could have had a heads and then a tails and then a heads. Or heads, tails, and tails. Then the last grouping all start with a tails. So we could have tails, heads, and heads. Or tails, heads, and tails. Then we could have tails, tails, and heads. Or the last one is all tails, 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 and tails. So it says, find the probability of each event. The probability that you have two tails. Probability of two tails. And no, it doesn't say they have to be tails and tails. And it can be that, right? There's three options. So you have anywhere that you have two tails. So two tails. So we have, I'm just going to list them so we can see. Heads, tails, tails is two tails. And tails, heads, tails. Tails, tails, heads. And the last one has two tails. It has three, but it does have two. I didn't say exactly two tails. It just has two tails. So there's 4 out of the 8, which is 1/2 or 0.5 or 50%. So team says at least one tail. Okay. So at least one tail, I'm going to star them. So at least one tail means we could have one tail or more. Now, on this probability of two tails, you could have read it as we don't include the 3 tails. I read it as it has 2 tails. So at least one tail means it has one tail or more. So one tail or more, one tail or more, one tail or more. It looks like all of them, except for the first one, have one tail or more. So 7 out of 8 would be 0.875 or 87.5% of the time. And then it says at most one tail. So you can't have more than one tail. So in that case, we're going to have at most one tail. So it could be no tails. At most one, at most one. This one cannot be because it has 2. This one only has 1. And the rest tail had 2 or more. So there's only 4. So again, 1/2 of the time. Like I said, you could have said on the first one, the probability of 2 tails, thinking it exactly 2 tails. So if it was exactly 2, then we would have had 3 out of the 8. Depends on how you read that one. Okay. Catch us back for the next group work lesson.